2007. It's problem 14. And it was worded slightly differently. I'm using what they call the floor notation, but they said find the greatest integer n that's less than this input argument right here. So that's what the floor function actually means. These square brackets here means floor. Let me just give you a couple of quick examples on that. For example, the floor function of it, let's say 3.2. Okay, that reads the floor of 3.2. That's equal to 3. Okay, it effectively just chops off the decimal value, and it wouldn't change any if you. It's not a rounding function. It literally chops off. So I've heard it called truncate, I think. But like if you had 3.99 here, floor of 3.99, it still gets sent back to 3. Okay, so that's what it does, folks. It's called the floor function. And it's always going to return an integer no matter what. No matter what, it will return an integer. Now, the particular version of the floor function that's going to help us, or the type of arithmetic that's going to help us out with the floor function right now is, let's just write down this expression of the square root, or excuse me, yeah, we'll do it like this. The square root, the floor of the square root of x squared. Okay, because that's pretty much connected to this problem we're doing right now. So that, again, that reads the square root of the floor of the square root of x squared. Okay, let me define our interval first. Let's say that we know that 4 is less than or equal to x, and then we'll do strictly less than 5 here. Okay, so this is a closed open interval. This is less than or equal to x, and x is strictly less than 5. Okay, so for this particular case, the floor would be 4. Okay. Now, if you substituted 4 in there, you get 16, but the square root of 16 is just 4, right? So the floor of an integer is the integer, but the only time this would change would be if you made it to the square root, the floor of the square root of 5 squared. See? So that's definitely equal to 5. So you see, it's going to remain all the way up, like inputs, 4 squared, 4.1 squared, 4.3 squared, 4.4 squared, all the way up to 4.999 squared. The floor of the square root of that squared is always going to be 4. Okay. Now, hopefully that made sense, and hopefully you'll see why I brought it up when we get down to this next phase here. Now, so I like to do these substitutions. I think it makes the algebra a little more manifest, a little more clear. So it's not necessary, but I like it. So what I did is I chose u equals to 2007. And so this floor actually transforms to u squared minus 10u plus 31. Okay. Now, based on this up here, about the floor of the square root of something squared has this property in this closed open interval. We're going to complete the square down here and see where that applies. Now, let's just take a look at this part right here, this radicand u squared minus 10u plus 31. Let's write that down over here. U squared minus 10u plus 31. Now, anytime you have a quadratics in this form, you can do this process called completing the square. So let's just keep writing here and go through the process. This is equal to u squared minus 10u Now, this looks like some baggage. I'm going to put plus 25, and then minus 25. Okay, and then we have, of course, the 31 is still there, right? Now, so the reason why this is useful is because these three terms are a perfect square. That is, you can write these three terms as u minus 5 quantity squared. Okay. And again, folks, that's these three terms sort of directly above here. U minus 5 quantity squared, when you expand that, 5 multiplies against u twice minus, so it'll be minus 10u. Then right here, what is this? Minus 25 plus 31 is just plus 6. Okay. And again, folks, this is just called completing the square. And so you can see that's exactly what I wrote here. We completed the square going from this stage to this stage. Okay, and now we're at a stage where we can replace the substitution with the original value. U was assigned to the value of 2007. 2007 minus 5 gives you 2002. But you see, the floor of this has to be 2002 for the very same reasons. The floor of this is equal to 4. And that's simply because, and let me see if I can get this written down. In other words, 2002, I can, hopefully I have room. Let's write it right up here. Okay, so 2000. Okay, we have 2002 squared plus 6. Okay, and this is almost, I mean, this is obvious, but I just want to write it down. It's less than 2003 squared, right? Which would be the next time the floor value would change. Okay, again, folks, and this is the same kind of logic that we applied right up here. 2002 squared plus 6 is clearly less than 2003 squared, and it would change floor values to 2003 at this value right here. So this is significantly less than that. So that's why we can just neglect the 6 and get 2002 as our answer. That was a little long-winded. I hope it made sense, but 2002 is the answer, and the process that made things fly right here was complete the square.